So you're out looking to run the latest video game, and you need a high-end computer to run this high-end game. So you're out shopping and you see a gaming PC, and it's priced at $3,000. It has one quad-core CPU, 16 gigabytes of RAM, and 4 hard drives in it. This thing is a beast. But then you go and you're shopping around a little bit more and you see a rack mount server. And it happens to be priced at $2,000. It's got 4 times the computer processing power, 4 quad-core CPUs of the same speed in them. Okay, this is, it's got tons of extra processing power, 4 times the processing power, twice the memory at 32 gigabytes of RAM, twice the number of hard drives at 8 hard drives. Now, mind you, these hard drives are smaller in size than the ones that were on the gaming system, but it's got 8 hard drives nonetheless. And you're thinking, wow, why don't I go ahead and get that server and set it up to run my game? Isn't this a great steal? This is a good deal right here. $2,000 less for much more of a computer, more than twice the computer. We're going to be comparing, to answer this question, we are going to compare 6 different classes of computer on here. And this is not going to be a make and model comparison. This is going to be looking at classes of computers. We're going to look at their purpose, their intended purpose, what are they being developed for, and what are their typical strengths and typical weaknesses based on that purpose and their physical size and characteristics like that. What is typical? Because, yes, sure, you can get some phones that'll do more than some PCs. You can get $2,000 phones and you can get $100 phones. But in general, what are we looking at? What is our focus? So let's take a look here. We're going to be comparing phones, tablets. Yes, they are different classes. I am putting those in different classes on that one. Laptops, that would also count gaming laptops in that same class. Raspberry Pis and PCs, from workstations all the way up to gaming PCs, that's all one class. Servers, from tower servers, desktop servers, rack mount servers, all that stuff there, blade servers, everything that's in that server class, we're putting it together for this video. So let's compare these guys here. Our phones, they were designed as communication tools. They evolved from flip phones. Their mission was to communicate. Originally, they got the voice communication. They've had that for a long time. They started doing text, and then they did camera, and now we've got smartphones that do apps. They do social media. They are very adaptable. We can play games on them even. So their strengths are going to be in the multimedia area. They're going to continue to develop the microphones, the speakers, the cameras, and make sure the screen has enough resolution to be able to see the pictures from the camera. Those are things that they're going to continue to focus on with phones, and they are becoming more and more of people's main computer this day and age. So yes, but their focus is going to be on multimedia. Now, tablets. Tablets were meant as lightweight, portable computers. They're designed to have bigger screens than phones, but very similar in design in a lot of ways, but they also didn't have the communication purpose behind it. It was more meant to be a takeoff from lightening up a laptop, which it did very well for the lightweight, portable qualities of that. It's designed for reading books, looking at documents, watching videos, maybe playing games. But when it comes to multimedia, you got to watch and make sure you're actually getting a microphone with it. Some tablets don't have microphones. They weren't meant as phones. They were meant to watch a video. It doesn't need to hear you to watch a video. A lot of games don't need that. Reading a document does not require hearing you. So those are things that you've got to take a look at on your tablets. And they are both very weak in their multitasking capabilities. At least they are with Android on them anyway. Android really, it can do multitasking, but it is certainly nowhere near what any of the other classes on this list can do. It's definitely behind all of the others. Even a Raspberry Pi does better multitasking than your phone and your tablet. Raspberry Pis are pretty awesome for their purpose. Now your laptop, I said here, that was kind of what they did with the tablet, was they lightened that up. It was meant for portable computing. When you need to take your documents from your office to your home, that type of stuff, that's great. When you need to take your work home with you, when you need to take your stuff out of your home somewhere else, you want to go take all your personal stuff out on vacation. It's great to have a laptop for that. You can take your computer with you on vacation if you have things you want to do on it. It's portable. It's got a battery. It's got that capability. And it's good for general computing use. Very portable. But it's light. And I don't mean light as in easy to carry. What I do mean is that they are light as in there's only so much you can fit in a box. And they downsize that box for laptops. They're not going to fit as much hard drive space. Most of the time, most computers don't take more than one hard drive bay for a laptop. Some of the higher end ones will take 2 hard drive bays. But a lot of times they don't have the same RAM. They don't have the same cooling capabilities. There's a lot of things that laptops are very much lacking. And when we get into Raspberry Pis, that's an even bigger drawback on that. Because now they took everything, instead of putting it in that laptop frame, now they're putting it on a card the size of a credit card. It really is the size of a credit card. Yeah. Now, it was designed for education and research on the Raspberry Pi. It was designed to show people how to use microcontrollers and how to use computers, how to program. It was designed for the classrooms. It wasn't designed for portability, and it doesn't work very well for portability. You've got to get an external battery. There's a lot of things you've got to do to make that a really good computer for good computing, general computing use, especially in portability. It's very much lacking. But where it really excels is in its ability to use general purpose input and output pins, the ability to interface it with another electronic circuit, to be able to illustrate what's happening in a program, to be able to use it as a microcontroller. Raspberry Pis rock in that department. Now, to answer our question, kind of. All right, we've still got some more comparison to do, actually, between the gaming PCs. They were designed for full and heavy computing. Your regular PC was designed to be your full computer, the way a computer is meant to be for your house. Your gaming PC was for heavier computing, but your server was designed for super heavy computing. And yeah, sure, the PC, you could load more into it, if you were going to take the server boards and load more into it. But what is the main hardware difference between your gaming PC and your server, and why would you not want to take that nice rack mount computer that we talked about when we got started and turn it into a gaming system? It has to do with multimedia processing more than anything else. So servers were really meant to be put in a data center and monitored by staff that's walking around. They are not meant to be used by anyone who is anywhere close by to that system. They were designed to be accessed from around the world, or at least from the next room over. They were designed to be connected to by other computers. They were designed to run as headless machines, which means they don't have very good multimedia capability. As far as 3D graphics acceleration, any type of graphics acceleration is generally just not present on those things. Audio, video, They probably wouldn't recognize, a lot of those systems won't even recognize audio. Maybe they sometimes know how to beep, some of them, but a lot of them even block that. A lot of times it's only the main system that beeps when it has a hardware fault to call the technicians over to repair it. It wasn't meant to be used as a PC. It was meant to be run in a data center. So while they have so much more extra processing power, the reason why it could be cheaper, why you still got so much extra RAM and hard drives and all that, because those hard drives were meant to be hooked up in RAID arrays. That's why it's got 8 hard drives that are all smaller. They were designed to be in RAID arrays. It's designed to work with redundancy. If you have a power supply fail, they're designed to be run 24/7. You can pull out one hard drive. When it goes down, it's got hot swap capability. You pull one out and put one in. That way you don't have to shut it down. It continues to run. These are all things that servers excel on, is their ability to handle that 24/7 redundancy, and oftentimes multiple networking ports. They're designed to talk to many more things than your desktops are. And they have a lot more processing power, but they're designed to process it and then send it out to whoever's connected to it, and then let them turn that into something graphical. But they'll do the math. Your computer has to display it. So they would be great for running the game server on, but when it comes to actually playing the game, they generally aren't going to have any of the hardware requirements that you need. They were designed to process, but they were not designed to display or to make sound or to hear sound or any of that. So servers, they rock for their purposes. Raspberry Pis, they rock for theirs. Desktops, they rock for theirs. And portable computers, they rock for what they do. And you can actually, I have a video where I talk about turning a Raspberry Pi into a portable computer if you're interested in that. But hey, these are different. These are the different purposes and why they've got different strengths and different weaknesses. Thank you for watching.